Okay, so this is lesson 1-3, starting on page 30, distance and midpoints. Number 1, use the number line to figure each measure. To find the length of xy, we take the absolute value of the difference of the coordinates. So y is 7, minus x is -1, and that gives us +1, so that would be the absolute value of 8, which is still just 8. On number 3, graduating classes have buried time capsules on the campus of Eastside High School for over 20 years. The points on the diagram show the position of 3 time capsules. Find the distance between each pair of time capsules. So we're going to apply the distance formula. Okay, so I'll label my points x1, y1, x2, y2. And just to show that it doesn't matter, I can reverse that. I could call this one x2, y2, and this one x1, y1. So the difference that, or the order that you subtract your x coordinates in does not matter. Same with the order that you subtract your y coordinates in. It does not matter. And that's the thing that students tend to get hung up on often, and I just wanted you to know that. So for these points, we would substitute in and we would have the square root of, so my x2 is 4, minus x1 is 2, squared plus y2 is 9 minus y1 is -3. So we get 2 squared here. That would become +3, so that is 12 squared. So we get 4 plus 144. So my answer is the square root of 148, or approximately 12.2. Same idea with number 5. So this time I'll call this one x1, y1. And really, all you really need to know is that this is an x and this is a y and this is an x and this is a y, okay? And that you subtract your x's and you subtract your y's, and it doesn't matter the order. So I'll show you on this one what I'm talking about. So I'm going to take this x coordinate first minus this x coordinate second. And I'm going to reverse that order for my y. So I'm going to take this y coordinate first minus this y coordinate second. The important thing is that I'm putting my x's together and I'm putting my y's together. That's the important part. That would become +3. Now, very important, notice I have a negative here and I put it in parentheses. If you don't have the parentheses there and you type in -7 squared on your calculator, you're going to get -49, which is incorrect. So the parentheses have to be there, parentheses, -7, parentheses, then squared on your calculator, and you will get positive. So the thing to remember is that when you square a number, you're always going to get a positive value here. You will never get a negative. So this number will always be positive. Remember that, always positive. And that is approximately 7.6. Make sure to round appropriately. Sometimes it stays the same, sometimes it rounds up. It all depends. So we want to use the number line to find the coordinate of the midpoint of each segment. So halfway between A and C, and the method here is to take our coordinates, add them together, and divide by 2, and it doesn't matter the order. So either -12 plus 6 or 6 plus -12. And then divide that by 2. And you can check it on the number line. So we would have, what is this going by? 3s. Right. So -3 would be right there. And that's halfway between those 2 points. On number 9, find the coordinates of the midpoint of a segment with the given endpoints. We want to use the midpoint formula. And once again, the order does not matter. All you're going to do is add your x coordinates and divide by 2, and add your y coordinates and divide by 2. So my midpoint would be located at 4, -5.5, or -5.5. All right, on number 11, find the coordinates of G if f 13.5 is the midpoint of GJ and J has coordinates 6, -2. So if we call G our x1, y1, and J our x2, y2, then that means that our midpoint, f, will be x1 plus x2 divided by 2, same with the y's, and we get this equation. So basically, we would just substitute in what we know. So we don't know our x and y coordinate of G, so we just leave that x1 and y1. But we do know the x2 and y2, so we do know the coordinates of J. So we substitute those in. Okay, and from here we can actually set up two equations. So we're going to solve for our x1 and we're going to solve for our y1. So for both of these equations, we need to get rid of the dividing by 2. So we'll multiply both sides by 2 to clear that out. And then we subtract 6. And there's my x coordinate of the other endpoint. Now to find the y coordinate, same process, so multiply by 2. in this case, add 2. And there's my y-coordinate of the endpoint. So my answer would be x-coordinate and y-coordinate. Use the number line to find each measure. So once again, to find the length of JL, we just take the absolute value of the coordinates, or the absolute value of the difference of the coordinates. So -7 plus 2 and let's also do number 17 here. So JP, so the absolute value of -7 minus 5. And the absolute value will always be positive. Whether this number is negative or this number is positive, you always get positive. It's the distance away from 0 on a number line. Alright, on 19 we want to find the distance between J and K, so we're going to use the distance formula. So it does not matter what order, just subtract your x-coordinates. My x-coordinate here is -3, my x-coordinate there is 2. Same idea with the y's. So my y-coordinate here is -4 and here is 4. So we would get -5. As I've said before, make sure to put that in parentheses and the exponent on the outside. So anytime you square a number, whether it's negative or positive, your answer is positive. And approximate that with a calculator, round accordingly to the nearest tenth. Same idea with 27. So my x-coordinates first. And then my y-coordinates. Okay, work inside the parentheses. This would become +5. And 7. And that is approximately 7.3 units. 29. So you might want to get in a habit of always setting the problem up like this, because it's always going to look like this. And then you just have to plug in your x's over here and your y's over there. So my x's are 5 and 2, and my y's are 4 and 7. Okay, so I get a negative here. It has to go in parentheses. and that's approximately 4.2 units. Use the number line to find the coordinate of the midpoint of each segment. So the process here is to take half of the sum of the coordinates. So H looks like that would be 3, and K is at 9. And I could also take 9 plus 3. It doesn't matter with the order. So my midpoint would be at 6. Same idea with number 37. So F is -3. K is 9. And we get 3. So FK, from there to there, 3. So H is actually the midpoint for that segment. On 39 and 43, we'll apply the midpoint formula. So for 39, add your x's together, or 15 plus 22, that would be fine also, and divide by 2, and do the same with the y's, 7 and 4. So we get 18.5 for the x and 5.5 for the y. Same idea with 43. So add your x's, -6 and -2.4. Take half of that and add the y's. So -14 and -6.8. And divide by 2. So take half, and that would be -4.2 for the x-coordinate, and -10.4 for the y-coordinate. Find the coordinates of the missing endpoint if B is the midpoint of AC. So the missing endpoint for number 47 would be A, so we would call that, let's just call that x1, y1, and C we'll call x2, y2. So our midpoint formula says that x1 plus x2 divided by 2 and y1, y2 divided by 2 is equal to our midpoint, which is B. So it's equal to -2, 5. So we're going to substitute in our x2 and our y2, and we're going to solve for our x1 and our y1. So my x2 that I substituted in is -5. And my y2 is 4. And that will be equal to my midpoint. So set the first expression equal to the x-coordinate and the second expression equal to the y-coordinate and solve. multiply both sides by 2, and that will clear out the 2 in the denominator. Add 5 to both sides. And same idea over here. So we'd multiply by 2. And that would clear the 2 out. And this time we want to subtract 4. So A would be located at 1, 6. Okay, so this time we're looking for our missing endpoint is C because we have A. So we'll call A this time x2, y2. And we'll go straight to our 2 equations. So we're going to take x1 plus x2. So x1 plus 4 divided by 2 is equal to the x-coordinate of the midpoint, -4. And for the y's, y1 plus y2, or -0.25, divided by 2 is equal to the y-coordinate of the midpoint. So we multiply both sides by 2 to clear out the denominator. And we subtract 4. And there's my x-coordinate of C, the other endpoint. Do the same thing for the y, so multiply both sides by 2. And add 0.25. So there's the y-coordinate of the other endpoint. So my final answer is that.